Okay, so bacho, we were talking about in the last class, alkanes and alkenes that were hydrocarbon chapter, right? We have finished that, and now we are moving towards the new one, which is halogenoalkanes, right? And this is what you can say that this is one of the new homologous series that we need to discuss now. Yes, halogenoalkanes. If you talk about halogenoalkanes, so they are the compounds very similar to alkanes, right? They have carbon-carbon single bonds in them, right? And you can say that there should be at least one or more than one. You can replace any hydrogen by halogens, right? So whenever there is actually the replacement of any hydrogen by halogen, it will become what? Halogenoalkane, right? It will become what? Halogenoalkane. So you can say that these are alkanes actually with at least one halogen or more than one hydrogen when replaced by any halogen, right? So you can say that this is one of the molecule. You can say that this is what? Ethane. This is what? Ethane, right? We talked about this earlier. This is ethane, right? And for suppose if I just replace one of the hydrogen by chlorine, so it become what, bacho? It become chloroethane. Now it become what? Chloroethane. If you want to draw the structure of this skeletal formula, if you want to draw the skeletal formula of this, just remember we need to draw the dots for carbons, right? So this is what ethane. But if you want to show chlorine over there, so you must need to show chlorine like this, right? But so you need to keep remember this, that chlorine is something different. You must need to show in the skeletal formula, right? So this is chloroethane. For suppose we have this molecule, right? Two carbons and one carbon we have bromine and one carbon we have chlorine, and the rest of the bonds are completed by hydrogen, right? So how can you name this? We remember this, from where the bromine is near, you need to start numbering, right? Because bromine in alphabetic order, the bromine is first. So you need to keep remember like this, that from where the bromine is near, you need to start numbering from there. So this is first carbon now, and this is the second carbon now. So you can say that this is one bromo, two chloroethane. This will be one chloro, two bromoethane. And again, two carbons are there. So it will be written like this. And the chlorine over here and the bromine over here. You can draw like this. This is the skeletal formula for this molecule. Right, bacho? Is that clear or not? Yes. So for suppose we have this structure. For suppose we have this structure. So bacho, what is the name of this structure? What is the name of this structure? So you can see this. This is the one carbon, two carbons, three carbons, four carbons. So whenever you have four carbons, you can call this as butane. This is butane. And you can see this. If you start numbering from here, so it is one. And on the second carbon, we have chlorine. And if you start numbering from here, so again, on the second carbon, we have what? Chlorine. So you can start numbering from anywhere from, because from both ends, the nearest branch is on the second carbon. So you can say that 2, 3 dichlorobutane. This is actually what? 2, 3 dichlorobutane, right? For suppose you have this structure. You have this structure, and in this structure, we have chlorine over here and bromine over here, right? So what will be the name of this structure? You can see this 1, 2, 3, 4, 5 carbons. So whenever 5 carbons are there, you can call them pentane. But what about the numbering? What are the numbers on which we have branches? So you can see this bromine is near from here. So you can start from 1, 2, 3, 4. So you can say that 4 bromo, sorry, 2 bromo, 4 chloropentane. Am I clear, every one of you? Yes,
Yes,
everyone,
sir.
is that clear? Okay, so let's move on towards isomers. The isomers are very important for this chapter because we have optical isomers that arise in this chapter, right? So you need to keep remember the isomers part of this chapter is very much important. Definitely, I will talk about this after the complete organic, but over here it is quite important for MCQs. So let's talk about this. For suppose, if I have dichloropropane, for suppose if I have dichloropropane, so what are the possible structures that I can draw for this, right? First of all, I just want to draw the skeletal formula. This is 3 carbons, you can say that propane. This is propane. So if I just place both the chlorines on the first carbon or on the last carbon, so both are the same things, right? For suppose this is propane and I just place both the chlorine over here. So this is the same thing. You can say that this is 1,1 dichloropropane. So this is one of the structure that you can draw, right? Even the second structure that you can draw is, for suppose this is what propane and both the chlorines are on the second carbon, right? So this will be what, bacho? This will be 2,2 dichloropropane, right? One more possibility that you can draw is like this. For suppose these are 3 carbons and we are just placing what, chlorine like this. 1 chlorine on the first carbon and the second chlorine will be on the last carbon. So it will be known as what, 1,3 dichloropropane, right? And if you want to draw this structure like this, even we can draw it like this. This is propane, 1 chlorine on the first carbon and second chlorine on the second carbon. So it will be what, 1,2 dichloropropane, right? So these all are what? These all are positional isomers. These all are positional isomers. You are just changing the positions. You are just changing the positions and you have different structures, right? Right, bacho?
Yes,
Is that
sir.
right, everyone?
Yes,
So
sir.
तो the very much important thing over here is this, positional isomers फिर बहुत easy होते हैं. The problem is optical isomers. Any one of the molecule can show optical isomers. Optical isomers कोई सा भी इनमें से show कर सकता है, but for optical isomers it's very important that a carbon should be chiral center, right? What is chiral center? Chiral center is something like, you can say that, what is chiral center? Chiral center is a carbon having 4 bonds with 4 different group of atoms or atoms, right? You can say that a carbon bonded with 4 different atoms, 4 different atoms or group of atoms. So you can say that in सारे structures में से कोई सा भी कार्बन जो कि आपके पास कैसा हो, जो कि chiral center हो, वो आपके पास optical isomers show कर सकता है. And it's pretty simple to identify, बच्चों. How can we identify this? Look at over here. For suppose if you talk about this carbon, so this carbon has 2 bonds, so definitely we have 2 hydrogens over there as well, and this carbon has only 1 bond, so here we have 3 hydrogen as well, right? तो कार्बन जो कार्बन chiral होगा उसके अंदर एक जैसा सिर्फ एक ही हो सकता है, ठीक है ना, बहुत सारे नहीं हो सकते. So over here we have 2 hydrogens together, we have 3 hydrogens same, we have 2 chlorine same, so it cannot show optical isomers, ये नहीं show कर सकता. Again you can see this, यहाँ पर भी H2 होगा, यहाँ H3 होगा, तो 3 एक जैसे एटम्स हैं, ये ऑप्टिकल आइसोमर्स शो नहीं कर सकते, ठीक है. जस्ट लुक एट ओवर हियर, यहाँ देखें 2 क्लोरीन लगे हुए हैं, ऑप्टिकल आइसोमर्स नहीं शो कर सकता. यहाँ 3 हाइड्रोजन होंगे, यहाँ 3 हाइड्रोजन होंगे, ये भी ऑप्टिकल आइसोमर्स शो नहीं करेगा. ओवर हियर अब अगर देखो तो इसके पास 2 हाइड्रोजन होंगे, इसके पास भी 2 हाइड्रोजन होंगे, इसके पास भी 2 हाइड्रोजन होंगे, ये भी ऑप्टिकल आइसोमर शो नहीं करेगा। बट इफ यू लुक एट दिस मॉलिक्यूल, द लास्ट वन, तो द लास्ट वन के अंदर आपके पास डेफिनेटली यहाँ 2 हाइड्रोजन है और यहाँ 3 हाइड्रोजन है, तो ये दोनों कार्बन तो कायरल सेंटर शो नहीं कर सकते। बट अगर आप बीच वाले कार्बन को देखते हो,
नहीं है कि अगर माँ ने तुम्हें बुलाया था किसी काम के लिए तो तुम उठकर आ जाओ। हाँ, तुम्हारे लिए
बेटे आपके किसी का माइक वरीशा, आप अपने माइक बंद रखा करें बच्चों। देखें अब इसको अगर मैं ड्रॉ करूं इस वाले को, तो एक कार्बन आपके पास ये आ गया, दूसरा कार्बन ये आ गया, तीसरा कार्बन ये आ गया, ठीक है। इस वाले कार्बन के साथ 3 हाइड्रोजन है, ठीक है ना, तो डेफिनेटली ये तो कायरल कार्बन नहीं है। इस वाले हाइड्रोजन के साथ, इस वाले कार्बन के साथ 2 हाइड्रोजन है और एक क्लोरीन है, तो इसके साथ भी 2 एक जैसे स्पेशीज आ गए, तो ये भी कायरल सेंटर नहीं है। बट अगर आप बीच वाले को देखें तो इसके पास एक क्लोरीन है और एक हाइड्रोजन है। सो यू कैन सी दिस कि ये वाला जो बीच वाला कार्बन है बच्चों, इसके पास एक अलग स्पेशी क्या है, CH2Cl, ये एक अलग चीज है। इसके पास यहाँ एक अलग चीज है विच इज CH3, ये बिल्कुल अलग चीज है, ठीक है ना। और एक ये अलग है, इसके पास एक H है और ये बिल्कुल अलग है जो कि Cl है। आप देख सकते हैं, तो ये बीच वाला जो आपके पास कार्बन होगा, इट कैन बी कंसीडर एज chiral carbon, right? Why it is chiral carbon? Because you can see this, एक कार्बन है, ऊपर एक अलग चीज लगी हुई है Cl, नीचे एक अलग चीज लगी हुई है H, इस साइड पर एक अलग चीज लगी हुई है CH2Cl और इस तरफ एक अलग चीज लगी हुई है CH3. So this carbon is actually chiral carbon because all 4 species, or you can say that atoms or group of atoms are different. तो ये 4 बॉन्ड बने हुए, चारों अलग अलग के साथ बने हुए. So you can say that the central carbon over here is actually what, chiral carbon. So this one can show what, optical isomers. This one can show optical isomers, और optical isomers बहुत आसान है. अब इसको कैसे बनाओगे, इसको आप ऐसे बनाओगे, देखो इसके ऑप्टिकल आइसोमर्स आप बनाएंगे कैसे। ऑप्टिकल आइसोमर्स बनाते वक्त आप हाइड्रोजन दिखा सकते हो, ठीक है ना, तो आप ऐसे बनाओगे, देखो ये इसके कार्बन है 3, ठीक है ना, उसके बाद यहाँ पर इसके पास Cl लगा हुआ है और एक Cl इसके पास यहाँ लगा हुआ है, ठीक है ना। अब यहाँ पर आप हाइड्रोजन दिखा सकते हो क्योंकि आपको इसका ऑप्टिकल आइसोमर दिखाना है, तो फिर अब आप हाइड्रोजन दिखा सकते हो। अगला स्ट्रक्चर आप कैसे बनाओगे, अगला स्ट्रक्चर आप ऐसे बनाओगे कि इन दोनों को शिफ्ट कर दोगे, ठीक है ना। तो ये प्रोपेन अपनी जगह पर है, ठीक है ना, क्लोरीन अपनी जगह पर है, बस आप इन दोनों की पोजीशन को चेंज कर दें, क्लोरीन को इस तरफ कर दें, तो सुपर इम्पोजिबल इमेजेस आपने इसको बना देना है, इट बिकम व्हाट, chiral carbon. So if you just look at over there on this structure or on these isomers of the dichloropropane, so you can see that how many structures we have, 1 2 3 and this is 4, and you can say that 4A 4B, but I just consider this 2 different isomers. So right now we have 5 different isomers of dichloropropane. Is that right, bachcho, or not? Right or not?
Yes.
Any problem to any one of you? चलें, अब आपके पास एक स्किल टेस्ट है. You need to show me your skills. I'm not giving you 2 different dichloro or any type of compound. I'm just giving you what you should have, what skill test for you. You need to show me the possible structures. You need to show me the possible structures of bromobutane. You just need to shift the position of bromine the maximum that you can. You can even draw the branch isomers, or you can even draw optical isomers if it is showing any one of the molecule or any of the structure showing optical isomers. So just try this. Just try how maximum structures you can draw for bromobutane. Just do this and send me on my WhatsApp so I can check. And after that, definitely I will show you how can we solve this. And from by free radical substitution reaction as well, and from alkenes as well, right? But we are not talking about the chemical properties right now. We definitely do about this, but right now we are doing about isomers because they are very much part of MCQs and theory questions. So just look at over here. You can even solve like this, bacho. We know about primary, secondary, and tertiary, na? primary, secondary, and tertiary. We talk about that in carbocations, and that right now we are talking about primary, secondary, tertiary halogenoalkanes. Now we are talking about halogenoalkanes, so we can solve them by primary, secondary, and tertiary. Right. So how can we solve like this? Just try. For suppose a carbon having two hydrogens, along with a halogen, right? So bromine in us, so we can put bromine over here and the carbon chain over here. So 3 carbons chain would be on the left hand side. So such type of halogenoalkanes are termed as primary halogenoalkanes. So they are primary halogenoalkanes, a carbon with 2 individual hydrogens and 1 bromine with 1 carbon chain is termed as primary halogenoalkane, right? Same as it is if you talk about the secondary. So as previous we discussed in carbocation, this is the same. A carbon having bromine, right, should have only 1 hydrogen and 2 carbon chains. So I'm just considering 2 carbons over here and 1 carbon over here. So it is what? Secondary halogenoalkane. You can see this. Both the molecules having 4 carbons in total, right? If you talk about tertiary, so a carbon with bromine should have 3 carbons connected to this. So we have total 4 carbons, so we need to connect 3 carbons with this. So it will be like this, right? So these are 3 different structures we can draw, and we can name them as well. What are the names of these structures? This is actually bromobutane, and this is actually 1-bromobutane. The structure is 1-bromobutane because bromine is on the first carbon. And if you talk about this one, so it is actually 2-bromobutane because bromine is on the second carbon. And if you talk about this structure, so you can see this bromine and methyl functional group or branch, both are on the second carbon. So you can say that 2-bromo, 2-methyl, and in the main chain we have 3 carbons, so we can say that propane. So this is what third structure, right? Now these are the simple 3 structures, and even you can see this, not a single carbon over here in the first structure is chiral carbon because all of them having 2 hydrogen at least, right? So over here as well you will see that CH3, CH2, CH2, so they all are not what? Chiral carbons. But in the second structure, if you focus over there, so this carbon is actually showing what? Chiral carbon, because it has 4 bonds and 4 bonds with different species. One is hydrogen, one is bromine, one is CH3, and one is C2H5. So you can even draw the optical isomers of this. So 2-bromobutane can show you 2 more structures, right? You can draw like this in the tetrahedral form. You can see this carbon with like C2H5 and hydrogen, and over here you can show CH3 and Br. This is one of the structure, and we just need to change any 2 of the particles. So I just placing CH3 over here and bromine over here, while C2H5 and hydrogen on their own position, right? So these are 2 different optical isomers, right? They are optical isomers. And one more possible structure that we can draw over here is, you can see this, we have 3 carbons over here consecutive, so we can make branch of this as well. So we can consider this the chain isomer. How can we draw this? 1, 2, 3 carbons, and bromine will be on its own place, hydrogen is on place, I'm just considering 1 more carbon chain over here. So the structure will be like this. So you can see this. How can we name them? We can name them like this. We need to consider a long chain having bromine. So this is the maximum long chain which can have bromine inside it, right? And this will be branched down. So you can name this as 1-bromo, and now methyl is on the second carbon. So 2-methyl, and long chain contain 3 carbons, so it is propane. So again, we have 5 structures of bromobutanes, right? So the first one is this, second one is this, third one is this, and the fourth one is this. These are the 4 structure, and we have 2 different structures of the second one. So 2A and 2B. So in total, we have 5 different structures, right? Is that clear, every one of you? Yes, every one of you.
2A और 2B तो दोनों सेम ही हैं।
सेम नहीं है ना, तो ऑप्टिकल आइसोमर्स तो है ना एक दूसरे के बेटे। कायरल कार्बन के जैसे वो एक दूसरे के ऑप्टिकल आइसोमर्स तो कहलाएंगे ही ना। तो अगर ये सेम ही होते तो हमारे सिलेबस में डेफिनेटली ये इंक्लूड नहीं होता। वो बात ही नहीं करते ऑप्टिकल आइसोमर्स की, वो कहते ही नहीं हमसे कि ऑप्टिकल आइसोमर्स भी कोई चीज होती है ना। तो अगर उन्होंने बात की है तो डेफिनेटली दे आर डिफरेंट स्ट्रक्चर्स, सो दैट इज व्हाई वी नीड टू कंसीडर देम अ डिफरेंट स्ट्रक्चर, राइट?
ओके सर, राइट।
ठीक है, so just do this in your copy as well, and I am giving you one more skill test and you need to show me how can